Good morning, friends and colleagues. My name is Engineer Dr. Ohagwu from the Department of Agricultural and Bioresources Engineering, University of Nigeria, Nsukka. The title of my presentation is Design, Construction, and Performance Evaluation of Tomato Charcoal Cooler Storage Bin. On the screen is the authors that helped in this particular study. The presentation outline goes thus: introduction, objective, justification, scope of the study, material and methods, design assumptions, design method, result and discussion, conclusion and recommendation. Introduction. Tomato plays a major role in human nutrition, and as such is a major source of vitamins and minerals. Tomato is consumed across all the developing and developed countries of the world as a major source of diet and meals. Tomato is predominantly exposed at fresh and flesh, is predominantly exposed to spoilage and deterioration immediately after harvest, and this spoilage or deterioration is as a result of the biological factor inherent in tomatoes and the physical factors, which has to do with the environment where these tomatoes were cultivated and harvested. These changes as a result of spoilage can be activated, and the activation could be in change in terms of taste, smell, appearance or texture of the fruits. Tomato is said to be spoiled when these characteristics change with respect to time, and the tomato deteriorates to the point that it's no longer good for consumption. And this could be as a result of microbiology or microbial infestation or microbial attack on these fresh and flesh tomatoes. So another major factor, as I mentioned earlier, under physical factor, is the weather parametric influence on these tomatoes that are harvested at fresh as it were. This particular tomato will naturally, immediately after harvest, be activated. Naturally it will be activated and it will start ripening, it will start cracking, there will be loss of weight, it will shrink and rotting setting. And this limits the quality of the tomato at consumption and also at marketing. In our normal contemporary society, when you go to market and you see the tomatoes with all these features, cracking, ripening, weight loss, shrinking, cracking, immediately you see it, that will affect the price of the tomato. Assuming you want to buy it, the wholesomeness of the tomato and its freshness normally get high price for such a tomato of such quality. Tomatoes are cultivated abundantly across all ecological zones in Nigeria, with over 5,000 metric tons of tomato production per annum. But due to lack of storage facility, a lot of these produce are lost from harvest to consumption. And if not because of the value addition sector of the economy, we will be experiencing a lot of losses, because immediately tomato is harvested, deterioration sets in. And because this deterioration sets in, there is two regimes, the regime of glut and regime of boom, with attendant fluctuation in the demand and supply as a result of poor handling, inadequate preservation and storage of this produce all year round, And we normally see these things happen in our own environment in Nigeria. Therefore, it is very important for us to solve these problems. It is very important to develop an appropriate technology that will be user-friendly, very cheap, and locally sourced, such that it can be replicated and maintained within our environment. And these particular reasons gave birth to the conceptual design and possible construction of 40 kg capacity tomato charcoal cooler storage bin. And we went ahead to carry out the performance evaluation of the system to ascertain the viability of the technology to preserve and store fresh and flesh tomato fruits. So the objective of this study was just to design, construct, and carry out performance evaluation of tomato charcoal cooler storage bin. Then justification. The capability to produce flesh and fresh tomato all year round for consumption and economic gains with intention to increase the shelf life and retard spoilage under safe storage facility is paramount. This storage facility, of course I mean the tomato charcoal cooler bin, produced will be user-friendly, economical, and locally sourced, and also it will be locally maintained. This will definitely bridge the gap in the supply chain and make tomatoes available readily and minimize demand and supply deficit. This will make the tomato readily available, very fresh, and will consume it when it is safe and with high nutritional value. Then for the study, of course, we have to harvest the tomato very fresh and flesh with all the nutritional and medicinal contents to retain and consume optimally. This is part of the justification. You must be consuming it fresh and flesh. And when you do this, all the nutritional and medicinal value, when you consume it, it is retained and consumed optimally for our human health and our well-being. The scope of the study was to design and construct this storage facility, and this storage facility, to design it, to construct it, the materials must be sourced locally, and the design took into account the concept of evaporative cooling principle of charcoal with 2 storage tray of 40 capacity 40 kg per batch, and also the walls are perforated and filled with chips of activated charcoal. And when we do that, we encourage cross ventilation from inside to outside. The mature fresh and flesh tomato devoid of any damage was harvested and used for this study. And the entire package, the target end user for this facility we are developing, our target is for small to medium scale farmers, taking into consideration their financial capacity. Materials and method. The following materials, as you can see on the screen, were used for the construction of the tomato charcoal cooler storage bin. We employ the services of the hammer, saw, wire cutter, scissors, gluten cutting machine, wood board with the dimension as seen on the screen, the 2 hinges, perforated glass, drilling machine was also used, iron handle, welding machine, basket, bolts, nuts, charcoal, as seen on the screen. These things were employed in the construction of the designed tomato charcoal cooler storage bin. The material for the performance evaluation test were the Brix refractometer, the weighing balance, digital camera, universal testing machine, instrument model TMN, petri dish, plates, stopwatch, and flesh and fresh tomatoes. The design assumption. The following assumptions were made. The system is a passive system which is under the influence of the tropical weather condition, and we also assumed that there must be a one-way cross ventilation from inside to outside, and the water vapor draft will be through the evaporative cooling effect gotten from the wetted activated charcoal to the atmosphere based on the enthalpy of the atmosphere, based on the enthalpy of the tropical weather condition. Water vapor escape was not monitored, but water recharge on the charcoal wall were carried out at 1 hour interval. This was to make sure that the rate of evaporation is maintained based on the tropical weather condition. Also, a 40 kg per batch mature fresh fruit vegetable, as earlier mentioned, devoid of any physical damage, were used for the evaluation. Lastly, under design method, for us to design this particular storage medium, the components followed in the design were we developed the frame, the carriage frame, the perforated wall, the panel wall cover, 2-layer tray, door frame, sieve sizing and activated charcoal, and door handle. Now on the screen is the assembled drawing of the tomato charcoal cooler storage bin, and this developed charcoal cooler bin. In the next screen, you will see the engineering drawing showing the front view of the charcoal cooler storage bin, the bottom view. The next screen, next slide, you will see the back view and the top view of the charcoal cooler storage bin. Now, the next we'll talk about is the testing and operation of the developed tomato charcoal cooler storage bin. At no load, we wetted the walls of the charcoal wall from the top uniformly to the point of dripping, and we closed and allowed to settle for 30 minutes before readings were taken for the bin, and these readings were for the temperature and relative humidity, and all was to make sure that the evaporative cooling effects were established, and at 1 hour interval the rate of moisture escape was checked and wetted accordingly to make sure that the system supports the cooling effect. And it is this cooling effect that will now load the tomato into the storage bin and maintain the temperature for 7 days. Performance evaluation of the developed tomato charcoal cooler storage bin. For us to do this performance evaluation, we did a comparative study of the developed tomato charcoal cooler bin with other environmental storage conditions where tomatoes are stored in our environment. And they are, the first one is freezer storage, refrigerator, open air storage, then laboratory or room storage, then the last one is thatched house storage. And the temperature regime and the relative humidity regime for all the storage are shown on the screen. The freezer storage is at 0 degrees centigrade and 95% relative humidity. Refrigerator storage 10 degrees Celsius and 85% relative humidity. For tomato charcoal cooler storage bin, 12 degrees Celsius and 85% relative humidity. Then laboratory storage, 25 degrees Celsius, 78% relative humidity. For open air storage, 30 degrees Celsius and 78% relative humidity. Thatched house storage, 14 degrees Celsius, 85% relative humidity. The results showed that the quality attributes such as cracking, yellowing, weight loss, rotting, hardness, Brix value were determined to ascertain the quality of the tomato over 7 days storage time, given the storage conditions above. For the yellowing, a digital camera was employed, as I mentioned earlier. For the weight loss, we used top weighing balance, digital top weighing balance with high accuracy. The rotting or the Brix value, we used the refractometer. The hardness, we used the instrument, universal testing machine. The Brix value, we used the refractometer, as I earlier mentioned. Now on the slide, you can see the stored tomatoes, the freezer, the refrigerator, the thatched house, the open air, the room, and the charcoal cooler bin for 7 days storage. We use a particular tomato variety called Yolings. Now the results we got from the weight loss, we plotted the graph of the weight loss against the days of storage, and we were able to discover that the performance for freezer and refrigerator were of good performance, followed closely to the charcoal and the thatched house, with high variation on the open air and laboratory storage. Similarly, the Brix value with respect to the storage medium, for tomato, the Brix value must be above 5%, 5.5, above 5 or 5.5. Is within the range of 5 to 5.5, and because of that, the freezer storage gave a good result above that. That of refrigerator was above 5.5. Open air and laboratory were very close to 5, but not above 5.5. So it was not a good report. Charcoal cooler storage bin was above 5, and thatched house was above 5. So the Brix value, the minimum range was 5. The Brix value, the minimum range was 5. So all of them were above 5, the storage medium for the 6 comparative study that use refractometer. Now on the hardness test, after the 7 days of storage, the hardness test also showed that the freezer performance was good, followed closely with the freezer, refrigerator, thatched house, and charcoal, but showed abysmal below 0.8 kilogram force. The performance for laboratory and open air was so poor that the tendency for cracking was so imminent on the tomato towards the 7th day of storage, and this cracking limits the quality of tomato under storage. Conclusion: tomato behavior under different storages show that the freezer storage and refrigeration storage were of good performance compared to the 6 storage media. Following closely was the tomato charcoal cooler storage bin and the thatched house storage. The low performance we are seeing on open air and room storage, and this was as a result of fluctuation in temperature and relative humidity on the environment. And these tomatoes stored under room and open air were under the attack of pests and disease infestation. Comparing the storage media in terms of affordability, accessibility, portability, user-friendly, operational cost, standalone, and performance. Tomato charcoal cooler bean storage had a better comparative advantage over other storage media, followed closely by thatched house storage, then refrigerator and freezer. The open air and room storage are not advisable due to high rate of deterioration as seen from the results, because it was under the influence of the weather condition, pest and insect infestation. Thank you for listening. I'm open for any question and have a wonderful day.